When we get a car to move, the next issue is how to stop it safely. This is achieved with the brakes, which convert kinetic energy into heat using a hydraulic braking system. We start with disc brakes. The disc or rotor is attached to the wheel and is surrounded by the brake caliper. The brake pads are located on both sides of the disc. With a hydraulic system, when we apply a force to an incompressible liquid, the force is transmitted throughout the fluid. By adjusting the size of the pistons, we vary the available force and the distance travelled by the slave cylinder. Here we see the master cylinder with a reservoir for brake fluid on top. When the pedal is pressed, the piston moves forward and closes off the inlet from the tank. The fluid is then pressurized and activates the slave cylinders. When the brakes are applied, the rubber seal deflects slightly. When the brake is released, the seal returns to its normal shape and moves the piston back slightly from the wheel. If the fluid expands due to heat, some can return to the reservoir. If there's a leak in the system, the fluid will be topped up from the reservoir. Excessive leakage will be detected by the level switch. If there was a severe leak in the system, we would lose all brakes. This is a single piston floating caliper, self-adjusting and self-centering, which is used in most cars. Cooling air is channeled over the brakes to assist with heat dissipation. Periodically, the pads will require changing. Some pads have a metal wear indicator which makes a squealing noise when it contacts the disc. Other cars have wires embedded in the pad. When the pad wears out, the rotor completes the electrical circuit and activates a warning light. In the past, the friction material was secured to the shoe with rivets, but now a bonding adhesive is used.